Yes, guys. So we're back with another video on centers of mass. This one's part two. So getting a bit more difficult now. And what we're doing is looking at maybe a few questions where we've got to find the center of mass. So just a quick recap. Those of you who didn't watch the previous video, what are you doing? Go and watch it. Now, listen, for you who didn't watch it though anyway, a non-uniform rod is one where the center of mass is no longer acting at the midpoint of the rod. And what I did is I showed two diagrams, right? Two diagrams to help you think about this. A uniform rod, its weight acts at the center. So right over there, right? In the middle of the rod. If you don't believe me, go and measure it. And a non-uniform rod, we've got the center of mass. And look, this is clearly not at the midpoint of the rod. So that's what makes a rod non-uniform. So we've got maybe the weight acting over here, or maybe the weight acting over here. The point is that it's not acting at the middle, all right? So make sure you make a note of that now. I don't want you guys going, oh, Chris, what do you mean? I don't get it. I don't get it. All right. So make sure you write it down now and then we can get cracking. So let's have a look at this question, something typical of what you could see. So in the following diagram, a non-uniform beam AB, so here's A, here's B, and it's got a weight of 98 newtons, a length of 20 meters, rests horizontally on supports at C and D, where AC, okay, so wait, C and D over here, these are supports. We're going to have reaction forces then RC, RD. Now they told us that the distance here is 4 meters, right? Now we know A to D is 14 meters. So what does that mean? Well, that means this distance in the middle must be 10 meters, right? So put that there. And then we've got a buoy of mass 30 kilograms stands on the beam at E, okay, where AE is 13 meters. Okay, wait. Let's just get this guy and move him. So we need to move him, okay, to maybe here. Let's say this is point E, because point E is supposed to be 13 meters, right? So from there to the guy, that is 13 meters. And what's his weight? Well, he's got a weight of 30 G, right? So we need to put that there. And that point where he's standing is E. Okay, good. So that's all labeled. I think that's pretty good. And the last bit of information that we're given is this. We're told that the reaction at D is 3 times the reaction at C. So that means we can go RD is equal to 3 lots of RC. And there we go. So that's going to be a useful piece of information. We'll have a look at how we can use that in a couple of minutes' time. Now, we still haven't managed to put the center of mass in. And we know it's non-uniform, so it could be anywhere, right? So do you know what? I'm just going to take a guess. And I'm going to go, well, I'm just going to put it here. And that's 98 newtons, right? And we're going to call this distance from A to the center of mass X, because I think that's what we've got to find out, right? Look what it says. It says find the distance of the center of mass from A. So from A to the center of mass. So I'll call that one X. Now, we've got everything labeled. This is a really good diagram. All we've got to do now is start working this out. So we're going to go upwards and downwards to begin with. So upwards forces must be equal to downwards forces. Why am I on about this? Well, because it's resting, right? So it's in equilibrium again. So we've got RC plus RD. 1 second, it should be RD. And also, I just realized that should be RD over there, right? Hopefully none of you spotted that. But there we go. Is equal to 98 plus 30G. There we go. And then we can do some substitution because RD is equal to 3 lots of RC. So let's sub that in. So 3 RC over there equals 98 plus 30 Gs. And that means 4 RC is equal to 98 plus 30 G. So if we divide that across, I think RC comes out as just 98 in fact. And then what we can do is take that, plug it back in right at the top there, yeah? At the top. And we know that RD is 3 lots of RC. So multiply that by 3. What does that come out as? I think it's 294. There we go. Okay, we might as well fill that in on the diagram as well. So RC is 98 newtons, so we can put that there. And RD is 294 newtons, we put that there. Okay, this is perfect. Now we need to find this distance X, right? So we're going to need to take some moments. Now what I'm going to do is I'm just going to take moments about A. The reason I want to take moments from A is because the distance that we want is from A to here. So I'm just going to take it from A. However, what you could do, right, is you should practice. Maybe take moments about C. Why could you take moments about C? Because that means you eliminate this force completely. Or you could take moments maybe about D, because then you eliminate RD completely. So after I've done this question, maybe take a few minutes or something, take moments from different places and practice it so that you get to the same answer that I have. So what I'm going to do though is I'm just going about A. So I'm going to put moments about A over there. And remember, clockwise moments are going to be equal to anti-clockwise moments. So I'm going to put anti-clock like that over there. Now, clockwise then. So clockwise moments are going to be created by this 98 newtons and this 30 Gs. So clockwise, we're going to have 98 times by x, because we don't know the distance, plus 30G times by 13. So that's clockwise. And now how about anti-clockwise? Well, anti-clockwise, we're going to have RC and RD, right? So RC, remember, was 98 newtons, and its distance from A is 4. Plus RD was 294, and its distance from A was 14. There we go. So you've got 98x plus, what's this, 390G equals, and now if you bring this here all together, what on earth is this? Let's have a look. I think I wrote it down somewhere. We've got 392 plus 4116. There we go. Okay, and we can start to simplify this all down a little bit. So we've got 98x on this side. Take that 390 G over to the other side, and I think we end up with what is that, 686, I think it is. And then if you divide that by 98, let me just double check this real quickly. 686 divided by 98, and that comes out bang at 7. Okay, perfect. So you've got x is 7. What's that telling us? That's telling us that, that's a rubbish M, let's do that again. That's telling us that this 98 newtons is 7 meters from A. And remember, look what we said here. We said the length was 20 meters. So clearly, this is not a uniform rod because it's at 7 meters. If it was uniform, it means that the weight would have been acting at 10 meters. So bam, in the middle, but it's not, as expected. Now, here's a question for you to practice. So have a quick read, make a nice detailed diagram again, and then upwards, downwards, and then take moments about somewhere, okay? I'll see you in a couple of minutes. Okay, legends, time to get through this. Now, we've got a uniform beam CD. So we go C and D. It's got a mass of 20 kilograms, but we can't put that in yet, right? So we know that we can't put that in. It's got a length of 14 though, so we can put that in, right? So that info there, the whole length, 14 meters. It's resting on two supports, E and F. So this one's E, this one's F. And C to E is 2 meters. And because C to F is 12 meters, we can just say, well, this here is just 10 meters, right? So that seems reasonable. We've got a particle of mass 40 kilograms. And that's attached at H, where C to H is 11 meters. Okay, so C to H, there we go. We'll say that there is 11 meters. What we've got is a particle attached over here, and that's got a weight of 40 G. So we can put that. And then I think that's it really for now. We've put some reaction forces in. RE for this one, RF for this one. And we're told something quite important over here. We said, given that the reaction at F is 4 times the reaction at E. Okay, so that means RF is equal to 4 lots of RE. So quite important. We can write that there. And then we need to calculate the distance of the center of mass from C. Now at the moment, I don't know where the center of mass is. You don't know where the center of mass is. So what we'll do is we'll just put it in somewhere. I'm just going to put it over here. And that there, if you remember, is 20 G. And so because this distance is unknown, I'm just going to mark that as X. And now the last thing I think I'm going to do is get rid of this 14 meters, right? It's pointless. It's just making our diagram a bit messy. And we always want a clean diagram where possible. So now it's looking good. I think we're ready to go. So we'll start with upwards and downwards forces. And they're going to be equal again. It's because it's resting, right? So RE plus RF is equal to a total of 60G going downwards, right? You've got 20G, 40G, 60G. Now let's do some substitution because you've got RF is equal to 4 lots of RE. So RE plus 4 lots of RE is equal to 60G. That means 5RE is equal to 12. Sorry. Okay, I was ready to give you the answer. Ready. 60G. There we go. And RE is then equal to 12G. There we go. Okay, so RE is 12G. We'll fill that in on the diagram, 12G. And now using this at the top here, we can work out what RF is, because RF is just equal to 4 lots of RE. So that means we're going to get 48 Gs. So 48 Gs over there. And that's pretty good, to be fair. Now all we need to do is take some moments, right? Now I'm going to take moments about C, but you can take moments, again, about anywhere. You can take moments about E, you can take moments about F if you wanted to. So make sure you do practice that afterwards. Make sure you get to the same answer, right? Because it's good. Because then, when you're sitting there with your extra half an hour to spare in your exam, you can do moments from both sides just to double check your answer, isn't it? Yeah? Use that. So we're going to take moments about C, and we'll go clockwise equals anti-clockwise. So clockwise equals, we'll put anti-clock. That would do. There we go. So clockwise moments are going to be caused by this 20G and this 40G. So what we need to do here is we'll have 20G times by the distance, which is x, plus 40G times by the distance, which is 11, equals, now in the anti-clockwise direction, we're going to have RE and RF. So RE was 12G times by 2 plus, and RF is 48 Gs times by 12. Okay, so we'll start to neaten this up a little bit. Let's neaten it up. We've got 20Gx plus 440G equals 24G plus, and what is this? I think this is 576G. Okay, there we go. Let's neaten this all up. We got 20Gx on this side. Take that 440G to the other side, right? And that gives us apparently 160G. Scratch these out. So you've got 20x is equal to 160. And therefore x is just equal to 8. Okay, so what have we just found out? We found out that the center of mass is actually 8 meters from the start. So not too bad actually, because we know that this here is 11 meters. So yeah, just a short distance before that is the center of mass. And there we go. So hopefully you've got that. If you have, well done, congratulations, amazing. And you're ready to move on to the next part. Now the next video has some quite difficult ones actually. So make sure you check that one out. And again, if you've enjoyed it, if you've learned something, give us a like and subscribe, and I'll catch you again very, very soon.